I want to do a simple demonstration here to kind of outline why it's very important to have a clean ground wire to the computer, for the ECU, to a stereo you install, to any electrical accessory that we put to the car. So running a clean wire from the battery negative all the way back is critical. Now what I have here, this is a mock-up circuit board that we use in technical training. So I have a simple circuit. It's set up for 12 volts, and I have a power supply. We have a circuit breaker, which would form as your fuse, and then I have a 120 volt or 120 ohm resistor in series to a light bulb. Now if I turn on the switch, you could barely see it, but the light is very, very dim. Now that is because there's what's called a voltage drop across this wire. Now if I move this and I bypass the resistive load, you see the light bulb comes on. And if I put it back, the light slowly illuminates, but it is very, very dim. So what is happening is a phenomenon called voltage drop. Now every time voltage passes through a component in the system, whether it's the positive side or the ground side, we lose voltage. Voltage drops. That's because there's resistance in all things that are conductors, and in these instances, voltage is lost in that process. Now voltage drop is easily measured with a multimeter. What we want to do is set this to volts DC, and we're going to commence checking voltage across the circuit. So we have our multimeter set to volts DC. We always put the black or the common lead towards the ground side of the circuit, the red lead towards the positive side. So we'll check our voltage. I always start there when diagnosing circuits, and this power supply puts out 11.98 volts. So let's look at some voltage drops. If I start at the top of the circuit and move my way down this one wire here, I drop a small voltage, about 1/1000th of a volt. Across the circuit breaker, again, but that's a little bit more, so I drop 0.005 of a volt. Now, if I go across the resistor here, this is a significant drop. So this resistance is 10 volts. So I'm using 10 of my 12 available volts just to try to pass through this resistor. Now, for the sake of what we're showing you, here is the light bulb. So this light bulb represents the load, be it your stereo, the computer for the level ride system, any electronic device that you install. If I run my meter leads across this, we can see I only have 1.7 volts available to run the load. That's no good. We are losing a lion's share of our voltage across the resistance. In this case, over 10 volts, which is massive.